Contestants, are you ready?
Yeah, we're ready.
Contestants, are you ready?
I'm ready.
On your mark, get set, go.
Okay, so customers got this basic scenario. They have two routers that they're dealing with in their data center, one of which is internet connected, one of which is MPLS layer 3 VPN connected. LPS, MPLS. Oh, acronyms. Okay, this is going out to branches. Roughly 2/3 of the branches are dual connected. I'll use 3 routers as an example. Well, B2, B3. So this one will only be internet connected. These guys will be dual connected. Okay. Now, they have multicast traffic coming from hosts on this network. A few different ones. They're on dynamic addresses. Call it broadcast source. Right. So, broadcast source. Okay, so customer has a situation where they want to have integrity of data all the way through so no one's messing with it. They're as yet undecided whether they're going to be using an internet connection for that or the existing MPLS layer 3. So my design incorporates possibilities for both. You can always rip a piece out if it's not needed, but it incorporates both. So the idea, because there's no encryption requirements, just integrity requirements, is to run dual flex VPNs, not using encryption, just authentication headers, which keeps the integrity. So we'd run one source here, one source here. And the idea will be that we can use the multicast address family in BGP to actually make the sources available to the hosts, and we can only leak unicast for the rendezvous points and the sources through that particular BGP instance across the Flex VPN. Okay, so I'm going to just switch over here to blue. So essentially, we would wind up with something like this.
So real quick before we get too far up, your branch router 3 I think is connected to the internet. I think it's supposed to be connected to MPLS only.
Oh, you're right. Only MPLS.
I think you meant that.
Yeah,
I just
single leg, yeah.
No, it's the single leg. That's my bad.
I think you meant to do that, and it
I
just
did mean to do that, and it went bad. So yeah,
it's all good.
No good. So
I don't want to go too far in it. You know.
Yeah, it doesn't really matter because it's a parallel solution at this point. It'll work either way. So because we're only running the multicast sources and the multicast address family for return traffic, or for validation anyway, using sparse mode multicast on the 2 routers here, we can run it like that. Now, it's preferable to use this as a primary because the problem is that 1/3 of your net goes down if this guy goes away. But if this guy goes away, chances are he's not doing his broadcast right now anyway. Okay? So the basic solution is dual sparse mode rendezvous points, M routes through BGP coming through here, and that way you can use either channel as necessary.
All right, so since you said some of that, can you draw on the board where you'd put the rendezvous points?
I would actually put the rendezvous points directly on the routers. For 2 reasons. Everything has to go through them anyway, because they are terminating the Flex VPNs, and they're closest to the source.
So the RP addresses, would they be the same? Would they be different?
They'd be different, actually, because they're handling 2 separate Flex VPN clouds.
Okay. And then would you maintain state between them?
There's not really a need for that because it's going to follow the IGP. The idea behind this design is to have everything as dependent on the IGP, which in this case is BGP, which is silly anyway, but it's not an IGP, but we're using it as an IGP. And in order to keep the fast failover through the whole thing, because they want things moving as quickly as possible, we'll be running BFD over the tunnels.
So then you would have different RPs. Would you have different RPs for different multicast groups?
Right now, there's really only a requirement for one multicast group.
So we kind of jumped right in here, right? Mm-hmm. So real quick, before we get into the questions,
sure.
Do you see any kind of design issues with what they have today?
With what they have today, I don't really see any immediate design issues, but they really have to accelerate getting everything hooked up to that MPLS L3 if that's going to be their primary, because right now they're leaving a third of their sites in limbo. For multicast, they're not getting fast failovers, but until they implement this side, they don't have a failover. So that doesn't really hurt them any more than it would if with any other outage. So I would say adding the FlexVPN side as their backup would be a good addition to their routing. And I would use it for more than just, I'd use it for more than just the multicast, although that's their initial requirement.
You throw data, regular data down there too.
Well, yes, and as soon as you do that, we move from an authentication header model to an ESP model.
Yep.
But I went with the FlexVPN rather than the DMVPN, only because FlexVPN does have all the same functionality as DMVPN, but the Ike V2 gives us better options going forward for encryption and the Suite B sets.
So you get better flexibility moving forward versus DMVPN.
Better flexibility and better encryption options.
Okay, so that was a great overview of what you would do. I think we're going to maybe start through the questions that we have here. Do you want to go ahead and read them yourselves? We can read them.
You go ahead. We'll make it look interactive.
During initial talks with the customer, they've suggested that they never want to send multicast over the internet for fear of poor performance. They also want to use small layer 3 firewall devices as the internet-facing CE device. Finally, they'd like a WAN that provides confidentiality for traffic accessing DC resources such as personal records, but only when being accessed over the internet. Which option is most suitable given these constraints? A, DMVPN, B, GetVPN, C, IPsec with ESP direct encapsulation, D, IPsec with AH direct encapsulation, and then E, MPPE.
I'm going to go with DMVPN in this case, or FlexVPN's equivalent. Only because the others don't really meet the requirements or they require additional resources. GetVPN requires that we have 2 separate routers handling the key management outside of the ones doing the encryption, which we don't have right away. Could add it, I suppose. IPsec in its raw policy-based form doesn't handle multicast. So even though they're saying they're not using multicast right now, locking them out of it isn't an option I want to see, because they may change their mind when they see what kind of bandwidth is needed by unicast broadcasts across the whole, or unicast transmission across the whole thing. So I'd stick with the DMVPN or the FlexVPN equivalent.
Are there any multicast limitations with DMVPN?
Only that you only have hub-spoke. But in this case, everything's going hub-spoke.
Going hub-spoke anyway. Okay.
Yeah.
The data path.
Yeah.
Okay. Awesome, thank you. So let's, so we're going to do DMVPN A for that one, right? Moving on to the next question.
Sure.
So you picked DMVPN for the first one. Which phase of DMVPN would be most appropriate for the setup that you've got here?
For this particular design, it's going to be phase 1 because everything's hub-spoke.
Okay.
Phase 2, phase 3 is really only a requirement when you're starting to implement spoke-to-spoke options, and that's not a requirement here.
Perfect. I'll pass that on to you.
Yeah, we'll just keep passing back and forth. So you said phase 1, right?
Yep.
We're going to go ahead and answer that. And you already said why, right? So if phase 1, then why? You said no spoke-to-spoke traffic, right?
Exactly. There's no requirement for spoke-to-spoke.
All right. So we're moving on to question 3. Over which transport mechanism should... Sorry.
Yeah. Over which transport mechanism should the CEO town hall traffic be sent primarily? So ignore any challenges in multicast routing, RPF adjustment for now.
If you're ignoring the challenges of the routing and possibly the circumstances of the company recently, I'd say stick with the MPLS Layer 3 VPN, because when it comes to any internet kind of VPN, your QoS goes out the window as soon as you transmit. Everything that hits the ISP, all your tags are stripped and ignored anyway. Who knows where it's going, how many hops it's taking? You have no predictability on your quality. Whereas MPLS Layer 3 VPNs, the provider has given you an SLA. And if they don't meet it, yes, things don't go well, but at least you're able to take your pound of flesh out of them.
All right, so for a little bit more control, maybe a little bit better reliability, we'll go MPLS.
Exactly.
All right.
Not that it won't work on the other side, but it'll work better on this side.
Gotcha. So now that you chose MPLS for that one, kind of what are the reasons that we're going to talk about? We've got 5 options here for you. The Internet WAN doesn't have enough bandwidth right now.
Not true.
Number 1. Internet WAN is not secure.
Can be made secure, so.
Okay. The Internet WAN would become congested as new branches come online.
No, it's got more bandwidth to play with.
Okay. MPLS packets are faster than IP packets thanks to label switching technology.
Yes, but I don't know if that's it. What's
Okay.
the next option?
And all remote sites are connected to MPLS, so everyone sees the broadcast.
That's a key one.
Okay, so we've got E for sure. I'll let you take a look if you want to again. We've got 2 to pick from on that one.
Okay. Sorry, which one are we?
Right here.
Oh, up here.
Yep.
Okay. Choose 2. Bandwidth. Internet WAN is not secure. Congested. Fast and IP packets. Yeah. So E is a definite. D is true, but not so much faster that it's going to make that much difference for this. I would say as is, without adding anything, you're looking at B and E.
Okay.
Although security is not a requirement until you add the data.
Yeah,
But they did add the data.
What you know right now,
Yeah.
yeah. All right, so now we're going down to the next one here. So the company has chosen to use the MPLS network for video transport. The next question would be, how would you classify the CEO town hall meeting application? Is it high throughput data, broadcast video, multimedia streaming video, or low latency data?
It's broadcast video.
That was a quick answer.
Straight to the point.
Want to go into some detail on that?
Well, multimedia streaming is coming from a file source. You're assuming quick access to everything. It's now. Whereas your live broadcasts don't have as controlled a source. Okay? Low latency queuing, that needs to be reserved for the voice, because a little bit of video, we can handle some artifacts here and there. Voice dropping, especially when they're doing things like help desk calls, not cool. And high throughput data, no, because the others are still going to trump it.
Just real quick, can we maybe draw on the board where you would queue the traffic between the provider and the customer's locations?
Between the provider and the customer's locations. Yeah. You mean the multicast traffic?
Yes.
Okay.
Specifically the multicast.
We'd be queuing it here because, at this point you don't have queuing control. At this point, the best you can do is police things.
Can you mark it up?
Yeah, sure.
Maybe red.
Yep. So your queuing control is going to be wherever you're originating your source.
Okay. And then on the other end, would you need to remark or anything like that?
Once it reaches this end, it depends on what's at the other end. If we're talking about a router with a direct LAN connection, you don't need to remark anything because you've got nothing in your internal architecture that requires prioritization over anything else. But if you're talking about a larger branch where there's a significant network, yes, you might want to remark things at the other end so that it passes through the switching architecture.
Awesome. Good stuff. Question 5, what congestion management tool is most appropriate for this deployment? A is expedited forwarding, B is assured forwarding, C is AQM or weighted random early detection, and then D is shaping.
Well, we don't want expedited forwarding. Assured forwarding is in there, but AQM and assured forwarding aren't mutually exclusive, really. I'd go with the assured forwarding on this one.
Can you explain why?
Only because the expedited forwarding is your priority queue. Again, you've got a voice over IP environment. They're doing help desk. You don't want your video competing with your voice. Okay, so it's got to be one under that, which is where your assured forwarding comes in.
All right. Would you do maybe 2 priority queues? One for voice and one for the video?
I think that would make a lot of sense.
That makes sense?
Yep.
I had a follow-on question.
Oh, wait a minute. Hold on. Priority queues, you said?
Or low latency queue.
Oh, no, I don't think video needs a low latency queue.
Okay.
So I would do single priority queue for the voice and assured forwarding bandwidth for the video. Because
would you do weighted random early detection on top of that as well?
I would.
You would?
Yeah.
What type of traffic?
Oh, wait. No, this is all UDP traffic, so no. Okay. No need.
There you go.
There's no windows to consider.
Awesome. All
right, so here we've got right up by router 1 here, where it leads into the MPLS. The PE-CE link between R1 and the PE has failed. So you can assume that small link right there has gone down.
Yep.
Did you mark it for us?
Yeah.
Yeah, sure. We'll just we're still on red. Okay, gone.
Perfect.
see the screen with the camera, so just
All right.
to make it easier for us to show what you're pointing to.
Okay, gotcha.
All right, so you've marked up the link there that we're simulating has gone down in
Yep.
the topology. What is the most significant problem that's going to arise should that link go down?
You lose a third of your sites because they're connected through the MPLS L3 VPN,
Okay.
and they have no alternate mechanism.
Okay. So our options with that question are you'd have increased latency, bandwidth contention, packet loss, or increased jitter.
Those are our 4.
What was that?
Those are the 4. Let's see.
Those are the 4.
Increased
Those are the 4.
latency, bandwidth contention, packet loss, increased... Well, you'd have packet loss, 100% packet loss.
And where would you have packet loss on the screen? Could you circle?
You'd get your packet loss right there. Because they'd hit here, they'd have no route, and it drops from that.
Okay.
And then you talked about you'd lose a third of your sites.
Because they only have
who
that
would you
connection.
lose out of that? So you've got branch 1, 2, and 3.
You'd lose your
on
branch
top.
3 and anyone who's single connected to the MPLS L3 VPN.
Okay.
Now, I'm going to put a caveat in here. I typically black hole bogons on the routers. So if that black hole's not there, then the packet loss would actually be here because it would be going out the internet to private addresses and the ISP would drop it. But with the bogon filters in, they're dropping here.
Awesome. All right, so we're on question 7. What is the most rapidly deployable solution to restore network operation, keeping in mind the business and technical requirements and constraints? A is statically switch the HSRP active router to R2 for all data center VLANs temporarily. B is enable IP redirects for ICMP and HSRP on router 1, enable OSPF on the data center VLANs, and originate a default route on router 2 into OSPF. C is add a new point-to-point circuit between router 1 and router 2, enable OSPF routing on it, and originate a default route on router 2 into OSPF. D is configure a new VLAN on the carrier Ethernet provider along the data center interconnect to create a point-to-point virtual circuit between router 1 and router 2, reuse the EV line service, and then enable OSPF routing on it and originate a default route on router 2 into OSPF. And then finally, E, use 802.1q tunneling to reuse an existing VLAN by carrying an inner tag to create a new point-to-point virtual circuit between router 1 and router 2, applying the same routing techniques as described in option D. If you would like to see it, you can see it, because it's a lot of wording there.
None of those will work. And the reason none of those will work is because it doesn't matter whether you go across the EV line or whether you switch what router you're talking about. This router does not have connectivity to all of the sites. So it doesn't matter which way we get things to that router. It's black holing as soon as we get there. We don't have, are you assuming that we've already implemented the Flex VPN or DMVPN? Because if we haven't, moving around to any router is not helping us.
So the idea here is that if we lose this link right here, right? This link right here, how would we be able to get to this network?
Unless we've already put the DMVPN or Flex VPN in place, we can't. This is our only access.
Let's go ahead and assume, so you talked about your design on how you would do it in the beginning.
Yep.
Kind of having both options there.
Sure.
Let's go ahead and assume you did implement that and build on the other, how many questions we were ahead. So,
okay.
Should you had that all built out how you wanted it, and then you did lose the link that we circled there in red.
Okay.
Then kind of how would you operate?
Yep. So, let me just have a more quick look at this.
It's a lot to take in.
It is.
It's a huge challenge. So.
One router 2. I would say the easiest thing would be to statically switch the HSRP active to R2 for everything. Because that way you don't have to worry about your ARP timeouts, your gateway's the same, your MAC's the same, everything's going to cut over immediately. You don't have to, adding VLANs internally doesn't make sense. They both have access to both routers anyway. OSPF doesn't really make a difference because it's first hop routing. New P2P circuit, we already have a circuit. So yeah, I'd say switch your HSRP active.
So you would have, because we don't have HSRP on the diagram right now, so you'd have, maybe we draw it.
Yeah.
Makes sense. HSRP, the active ones where?
Well, there's actually 2 HSRP groups running. So you've got, I don't know, we'll say, G1 is .1, G2 is we'll call it .4, and then this one can be, .3 or sorry .2. This guy can be .3, and then we have group 1 going here, group 2 going here, and basically we just take all of the group 1 and increase the priority there so it switches over.
Is there a way to automate that?
Absolutely. You can do interface tracking on here, and you can actually have the priority drop here, use the preempt, and automatically cut over.
And that would be the quickest way to solve that problem.
It would, because you can actually do millisecond timers on HSRP, which is going to beat your ARP timeouts, ICMP redirects, that's an extra hop on your first, and a lot of people have that disabled anyway. So, your HSRP, the hosts don't know what's going on. They just go to the same MAC address and it's picked up by a different router.
Awesome. So that's like a short-term, quickest way to solve that. In your mind, what would be the long-term solution or the proper solution moving forward?
Proper solution moving forward is probably 2 circuits into the MPLS on R1 and R2. Okay.
So now you have an MPLS. You got MPLS at both sites. So R2 has access to R3 no matter what. Mm-hmm. Do you have any more single points of failure?
Other than your single connections at the branch, we don't have any details on how things are connected inside here, so I can't say. But I'd say your single points of failure at that point are just your single connected branches. Because if this point of failure fails, you have IBGP pulling things over and out you go.
Awesome. So that was answer A, right? I think that was A for 7. Modified A, but A for 7. Yep. So what is the most, so we're going to go to question 8. What is the most appropriate multicast delivery option for this customer? We have A, which is ASM, B is BIDR, C is DM, and then D is SSM.
Well, SSM is not going to work because you're dealing with dynamic sources and no IGMPv3. DM, no, that's just too chatty across the MPLS. You could do BIDR or ASM in this particular case because your tree is going to be the same either way. But I'd say for simplicity, just go with the ASM.
And then, assuming that you went with ASM, where would you put the RPs? Same places you have them right there, right?
Same place you have them right there.
In this design, if we didn't use Flex VPN, how would you configure the RPs?
We'd have routing between the two.
Routing between the two. Would you have still different RPs?
No, we could at that point. If we were using BIDR, we could use a Phantom RP. If we were using SSM, we could go with what's 4-letter? It starts with an M. Say any cast. We could do an Anycast RP. And then do it's a 4-letter acronym, starts with M. It exchanges between any casts.
Just explain what it does. I mean, if you...
Well, basically what we'd do is we'd have this available to the closest hop.
Okay.
So it would advertise the same IP address off the loop back into the routing protocol so that whatever the closest path is, we'll use that one. And then we would use the multicast distribution protocol to basically keep these things in sync so that they're fully aware of each other's sources.
Perfect. All right, so you chose ASM, right?
Yep.
So the question is why, right? So we have 4 options. A, the sources have variable IPs, hard to know in advance. B, ASM works natively with IGMPv2 while SSM does not.
That's true.
C, ASM is more secure than SSM. And then D, ASM will provide superior performance, less jitter, less packet duplication, etc. than SSM.
Let's have a look here. So definitely A, because you can't do variable IPs with SSM because you don't know the source. ASM works natively with well, that's true, but that's not why. ASM's not more secure. No, it's definitely A.
So we got question 9 is next. We got, what is the most appropriate combination of tools to secure the CEO town hall over the MPLS private WAN given the security requirements? Choose 2 answers to construct your solution. So we have a lot of answers here. Okay. So we have A is IPsec ESP transform, B is IPsec AH transform, C is IPsec ESP plus AH transform, D is no IPsec, E is easy VPN, F is flex VPN, G is DMVPN, H is get VPN, and then I is SVTI.
Okay. Well, you'd use DMVPN or the Flex VPN equivalent, really, with an IPsec AH transform, because you don't need ESP for this application. Unless you're talking about, are we adding in the data security requirement, or are we still staying with the multicast?
So let's do both. Let's do it first without the data.
Oh, you know what? The data requirement is only over the internet. Exactly. We can get away with an IPsec AH transform because we don't care about the encryption, we only care about the integrity. So DMVPN brings all of the hubs back, or brings all of the spokes back to the hub. We could use the Flex VPN equivalent and have the same benefit and something a little more flexible, but it's the same technology essentially. But the key bit is DMVPN and IPsec AH transforms.
Awesome. All right. I think we're on our last question now.
Okay.
So question 10, the customer has chosen a DMVPN plus IPsec ESP overlay atop MPLS after reading some blogs online about it being the most popular choice.
Yes.
What comment would you offer after being told about this decision? Do you want to just have a comment first?
Sure, I'll give the comment. The biggest comment I'd have is that the ESP requirement, or ESP is not a requirement. It puts additional load on the routers. Well, it puts additional load on the router's co-processors because they're processing encryption. Admittedly, it's done in hardware, but it's unnecessary because encryption's not a business requirement here.
All right, so the options that they give here is A, this is the best choice for the company's specific business requirements. B, DMVPN was a good choice, but IPsec was unnecessary since it does not address any requirements. C, providing encryption is unnecessary as it does not address any requirements. And then D, providing encryption provides a constant fixed encapsulation overhead, simplifying MTU calculations. And then E, there is not enough bandwidth over MPLS to support this design.
No, it's C. There's definitely enough bandwidth on the MPLS. It's only taking a 2 meg stream.
Okay. Do you have any last minute comments, concerns about this design? Things that you would do better? If you do. Well,
it's not something I can easily draw, but I would be taking a lot more time to rethink how the multicast RPs are coming back. I would say I would look into what options we have for things like layer 3 switches behind the whole thing, because if you can keep it off of this and bring it behind, that would make a lot more sense. But given what's available, I think this design works.
Right, would you fix the single points of failure at the branch sites?
Absolutely, but those are on track to be fixed anyway within the next 6 months. We're just coming into things early.
Awesome. Right, do you have any other questions?
I think that was kind of my biggest point right there at the end. So we kind of talked about, what would you do given this topology if you came in from the outside? And then you kind of mentioned what you would do. Would you go with that solution, or would you like to first address the other things like single points of failure? Kind of would you rather go with this design here, or would you like to first address that, maybe add different circuits? We talked about the MPLS in the beginning. Kind of how would you approach that?
I do both, really. You need to address the single points failure on your MPLS because it's your business critical stuff. Okay. Everything's running on that. That's where everything goes. Doing the Flex VPN is a good backup in case you have brownouts, your IP SLAs fail, you can move things over, but something to handle things if your provider completely loses it. So you're not relying on one thing. But it's not as good as the MPLS. It's not going to have your QoS. It's not going to have all of that. The advantage is it lets us bring all of the sites, including... actually, no, it doesn't. Never mind. I had them backwards.
Okay.
So basically, it gives us that long-term safety net, but really bringing those additional sites online is critical. It has to happen. It doesn't necessarily have to happen before we start, but it has to be made very clear to the customer that this shouldn't be a 6-month project. This should be maybe a 6-week project, or as quickly as possible, and do it alongside of everything else.
What would you view as more important here? adding the second link for the MPLS or having the second connection for your branch site. In this case, the one that's single connected.
I would say, if we're doing the Flex VPN backup, I would say get the internet connection first, only because it's faster to provision.
Okay.
You know, the 6-month timing on the MPLS connections may just be how long it's taking the provider to get things out there.
It's out of your control.
It's out of control. Getting a Cox connection or something like that can be done in a few days. So that's one way to get all of your sites online with a resilient topology fast. And as soon as possible, as a parallel process, I get that second link in there because that's your business critical. You don't want to be relying on this unless all of this goes down.
Gotcha.
Would you add any like a redundant internet connection to the R1 at all? Like again, would you add like a link here to here? If not, why? No. And then if yes, why?
It couldn't hurt, but it's not critical, only because once you've got this in here, this is a tertiary failure. So adding this produces a monthly cost in the event that everything else goes to hell. And the likelihood is minimal. It could be proposed as an ideal option, and if it's an inexpensive option and the customer thinks, yes, that's a good safety net, yes, but I don't think it's critical as a third level set of resiliency requirements.
I'm all set.
Okay.
It's a pleasure, man.
Thank you very
All
much.
right.
so much.
All good. Thanks, Kevin.
Thank you.
Hopefully I didn't blow it all up too much.
Well.